This experiment yielded different results, and the results are going to be inconclusive in this experiment. So, for the summary of results, in order to complete this assignment, you got to make sure that you have all six drugs that were given to you. It is Benadryl, aspirin, ibuprofen, caffeine, Excedrin, and Tylenol. So what you're given these disposable culture tubes, and what you're supposed to do is break it up, kind of like cut it or break it up into half or quarter size pieces. Drop all the pieces in there and add 2 milliliters of the solution, the menthanol solution. This allows you to break down the drugs, and get the concentrated part of the drugs, which you're going to use later for the TLC plate, the thin layer chromatography plate. So once you break them down, you're gonna once you add the 2 milliliters of the menthanol, you're gonna shake it as hard as you can to kind of break it up and create a reaction. This creates a reaction in the tube, and the medication becomes concentrated with the menthanol. So once you shake all of them, you're done with that part. You then have to get two plates. They're called the thin layer chromatography plates. You're gonna make a note or mark a line on the plate as about 1 centimeter from the bottom. What you're gonna do is you will add it to a beaker of the solution, a beaker with 5 milliliters of the menthanol solution. But that's after this step. You're gonna mark a line with the pencil on the bottom, and what you're gonna do is with those the six drugs that we created the concentrated solution with, you're gonna use pipettes, and you're gonna drop 1 drop of the solution onto one side of the plate. You're gonna let that air dry. Once you let that air dry, you're gonna add another, and then you air dry, and then you're gonna add another until you get 3. This creates more of a concentrated effect onto the TLC plate. You're gonna do that for all 6 drugs. You're gonna do 3 drugs per plate. So the first one I tested Benadryl, aspirin, and caffeine, and once that's done and air dried, I add that plate on into the solution of the menthanol solution. That's going to be our solvent, or in this case, that's going to be our mobile phase. The stationary phase is the plate itself. So once we add that, the menthanol solution, the solvent, will not quickly, but it will start to move up the plate and drag the drug concentrate with it, and you're able to see where the concentration is going, how far it goes up there. So once you moves up quickly, you're going to do it for the second plate as well. It's going to be of the other 3 drugs, ibuprofen, Tylenol, and then Excedrin. So in the meantime, while that's drying, your other plate is in the solution. Once it's done, it's going to be about a centimeter away from the top of the plate. Once it's at that centimeter, you're going to take it out. You're going to let it air dry. Then you're going to do the same steps for the second plate. Once those plates are completely air dried, and you're done with the menthanol solution, what you're going to do, I forgot to mention, I'm so sorry about that. What you have to do while it's in the solution, you're going to put a cover. You're going to put a plastic cover over it, over the solution. So once they're done drying, you're going to take your UV glasses and your UV flashlight, and you're going to see where the streaks are, and it's going to show you what color the drugs were, the concentrate, and all that. Sadly, in this experiment, the results were inconclusive in a way. I wasn't able to get a clear picture of the color of the drugs. The drugs were didn't move as much up the thin layer chromatography paper as I'd like. But once you're done, you'll see where the streak ended, and the streak where I ended was higher for aspirin than it was the other drugs. So in this experiment, the aspirin moved up higher than any other drugs, and it had an RF value of 0.3. So this basically means there was a higher concentration, and the absorbance from the stationary phase, or in this case the thin layer chromatography, was it had more of a it had less polarity than the other drugs, is what I'm trying to say. So like I mentioned, these results were, the color wasn't noticeable, but you could see a little bit of the streak. This could be for many reasons, meaning the drugs could possibly be expired, or human error could result from it. But in this experiment, like I previously mentioned, the stationary phase was the thin layer chromatography. This phase doesn't move, doesn't change, doesn't do anything. The mobile phase is the solvent, or in this case, methanol. So once you dip the chromatography plate into the solvent will move up the chromatography plate, and like I mentioned, drag the drugs up there and see which one has a higher, lower polarity than each other, and which one has a higher concentration. So the one thing we need to know is this is completely a presumptive test. It cannot confirm that there was a drug. It can't confirm anything. Basically, the results that are given are compared to a known data set or known compound, and it's compared. But you won't know what drug it is until there's a confirmatory test done saying that this drug, for example, is cocaine or methamphetamines or other opioid-like drugs. So it's only a presumptive test. So solubility does play a major role in how substances move. Like I mentioned, if there's a lower polarity of the drug, the higher it's going to be, more absorbance in a way. The higher polarity, meaning there's less solubility in the drug is going to stay the same. It's going to be kind of like not streak up as much on the chromatography plate. So due to a higher affinity in the stationary phase, it leads to a higher solubility of components of different drugs. So it just varies on what type of drugs it is, what solution used, like solvent, or what type of presumptive tests you use. It all depends on what you use. So how do we calculate RF value? The RF value is calculated by dividing the distance of the drug divided by the distance of the solvent. In this case, the distance of the solvent went from the bottom of about 1 centimeter away from the chromatography, from the line that we drew, up until a centimeter up. And in this case, it was about 1/4 of an inch, 2.5 inches. It was a 3 inch, but 3 by 1 inch chromatography plate. So the higher RF value means it's less polarity, and the drugs with the smaller RF value are lower in polarity. So the TLC, of course, mixture is based on the polarity of the compound, and that's why it's presumptive. Um, but once it's compared to other drugs, it can be compared, but again, won't be confirmed. So a thin layer, the one thing I need to mention is a thin layer chromatography paper is a paper that's 3x1, that has a glossy side on one side and kind of like paper like on the other side. What you're going to do with this is you're going to see if those fibers hold enough of the concentration to move up the move up the concentration move up on the plate itself, or if it stays dormant.